In this video, I will discuss this question from GATE 2014, question number 2. So it is, which one of the following microstructures of a nickel-based superalloys imparts highest creep resistance? So first let us consider what is creep. So this is basically time-dependent deformation at elevated temperature. So we apply a load that is well below the yield strength of the material. And deformation occurs due to operation of thermally activated processes. For example, one mechanism can be dislocation based mechanism, where glide and climb of dislocations occurs at high temperatures, which assist the creep process. Another one is diffusion controlled creep deformation. So here what happens, so I will write it here, diffusion based creep. So as we know, suppose we have a grain something like this. Okay, so suppose in this grain the lattice is oriented in this direction, particular this direction, and in this grain suppose this is oriented in this direction. Okay, so the grain boundary region, so there is some kind of disorder, like one grain there is orientation in this direction and the neighboring grain the orientation is in this direction. So what happens is, random orientation at the grain boundaries. So what happens, inside the grain this is more closed structure, and at the grain boundaries more open structure. So then what happens, diffusion becomes easy through the grain boundaries. Why? Because we have more random structure, there is no ordered structure at the grain boundaries, and there is enough space for the atoms to diffuse through the grain boundaries. So what happens, when we increase the temperature, the atoms start diffusing through the grain boundaries. With increase in temperature, atoms start diffusing through the grain boundaries. So this leads to grain boundary sliding. So the strength of material decreases at high temperatures if we have more grain boundaries. Okay, so that's why at high temperature grain boundary is weak. So the less the grain boundary, the amount of grain boundary area, the more strength of the material. Less grain boundary area means more strength at high temperature. Okay, so now let's see the options. So one is fine grain equiaxed. So this is not our answer because fine grain means more grain boundaries. So it will assist the creep deformation. Coarse grain equiaxed, this is better as compared to fine grain structure. Columnar, this is also not. So single crystal, this is the answer because single crystal means we have single grains in one orientation and there is no grain boundaries. So this is our answer, single crystal.